In this video, we're going to work on solving equations with variables on both sides. A key vocabulary word we need to recall is bisector. A bisector is a point, line, segment, ray, or plane that cuts a figure into two equal parts. So I'm going to go ahead and look at this segment here, and I'm going to cut that segment in half with another point. And then I'm dividing the total segment into two congruent parts. I'm going to label them both 3. I can create the same exact picture, but instead of using a point in the middle, I can use a line. However, you'll see that each part is still congruent. Everything's the exact same except for what I use as my bisector. We can also cut angles in half. Okay, so here we have our angle, and we've cut that in half using an angle bisector. We're using a ray this time. But we have two parts that are congruent, 62 and 62. And now we're going to look at how we can use an angle bisector to solve for a missing value, and more specifically when that creates a situation where we have variables on both sides. So BD is a bisector of angle ABC. And we want to use this information to find the missing angles. Okay, so I have an angle here and I've cut it in half. I need to label my points. So my larger angle is angle ABC, and then the ray that's cutting it in half is ray BD. So I know that the measure of angle ABC is going to be congruent to the measure of angle DBC. And again, I know that because it tells me right here BD is a bisector. That automatically means that this ray is cutting my angle in half. So I can take these two values and I can plug them in place of their associated angle to set up an equation. Now that we have this, we're going to start solving by moving all of the variables to the left side of the equation. We want to make sure everything with an x is moved to the left side of the equation. So if I look at my equation, I notice there's an x currently on the right side, and I want to move that over. So to get rid of that term, I'm going to subtract it from both sides. By doing that, I eliminate the x on the right side, and I'm left with just 2x on the left side. So now I have 2x equals 20, and I want to get rid of that 2 in front of my x. And to do that, I'm going to divide by 2 on both sides. When I take 20 and divide it by 2, I'm left with x equals 10. And my original problem asked me to find the measure of each angle. So I'm going to do that by plugging what x is equal to, 10, into the original expression and simplifying. So I see if I take 3 times 10, I get 30. If I plug 10 in here, 10 plus 20 also equals 30, which means I've done this right because this was supposed to be a bisector. So I can go ahead and conclude that the measure of angle ABD is equal to 30. I can conclude that the measure of angle DBC is also equal to 30. And consequently, if I add those two together, I can get the total measure angle ABC, which will equal 60, because 30 plus 30 is 60 degrees. All right, this serves as our introduction. We'll look at another video with more complex examples next.